Hello, welcome students. Welcome to my doubt fusions class of YouTube channel. Now, in the last few videos, I have given explanations that how we are using the equation of continuity as well as the Bernoulli's equation in the fluid mechanics. So specifically, we have highlighted the problems which is based on the cylinder which is having two holes, maybe one holes, or the cylinder which consists of two kinds of liquids that mean different densities which have only one hole in the bottom level, or maybe there are two kinds of liquids or one kind of liquid is there when density having rho, a particular liquid which is having two holes in the opposite end. So how we are finding out the ratios of the height of this particular holes level from the top of the surface of the liquid or from the bottom of the liquid, or we have also calculated the velocity of a flux from these particular 2 points. Now today we are going to discuss a particular problem which is mainly based on the it's also a kind of U-tube type of problem. Now here we will see that there are three kinds of liquids are placed in a particular U-tube. Now let's check what the problem is. Here it is mentioned that the three liquids having densities rho 1, rho 2 and rho 3 are filled in a particular U-tube. So this is basically the configuration of the U-tube we have seen in this particular picture. And in the left hand side, you've seen the liquid is kept and that particular liquid having a density rho 1. In the lower portion, you have seen a density of the liquid is rho 2. And in the right hand tube, the another liquid has kept which has a density rho 3. So the length of the liquid column, if you just check the liquid column, that is L. Here also the liquid column, the density is L, and here also the density is L. So we can say here that rho 1 is greater than rho 2 is greater than rho 3. So that is the overall densities of the three liquids. Okay. So now what we can do from here, we have just drawn a particular vessels like this. We have just drawn a particular vessels, what is mentioned over here. Now in this particular vessels, what exactly we'll do, we'll draw the figure that suppose this is the first liquid which escaped. We are just giving it is a yellow color. So this is the yellow color liquid which is kept inside this particular vessels. So this is the liquid number 1. This is the first liquid which is kept in this particular vessels. Now in the middle portion there is another liquid has kept in this particular vessels, that is U type of shape. So this vessel, this particular liquid having a density that is rho 2. So let me complete these things. So this is basically the liquid, red color liquid which is having a density rho 2. And also we have kept another liquid in the right hand column of this particular cylinder, or maybe this kind of U-tube, which is we have shown over green color. So this particular liquid is density rho 3. So what we have got from here, this particular density is rho 1, this is having a density rho 2, and this is having a density rho 3. Now it is mentioned that rho 1 greater than rho 2 greater than rho 3. Now we have to go point by point. How you go? Suppose take into consideration this is one point we have considered and this is the another point we have considered. Suppose this is point X, this is point Y, and we are considering this point is for example A and this point is for example B. Now, as far the figure is concerned, you just look into this carefully. At the point A, what is the pressure? Because this vessel is absolutely open. So, if it is an open vessel, what will happen? The atmospheric pressure which is acting into the downward direction, that is EATM. That is the atmospheric pressure. So, at the point A, there is only one pressure which is acting, that is the atmospheric pressure. Now at the point B, if you just consider, that is also the atmospheric pressure which is acting over there. So these are the two pressures and this pressure is same. Now normal situation, if it is a normal situation, if anyone asks you that what is the pressure at the point X and what is the pressure at the point Y, then what would be your answer? Normally, if you find that these two X and Y, these X and Y are in the same level, so naturally the pressure would be same. But actually that is not the scenario. Why it is not will be the scenario? The reason is simple. Here, suppose if we consider the pressure here, it will be how much? That will be H into rho 1 into G. So that is the one pressure which is acting over here. Plus you'll say that this is the atmospheric pressure which will be acting over here. So along with this, we have an atmospheric pressure, suppose P of ATM. So these two pressure put together, we will get that is the pressure at the point Px. So if anybody say what is the force acting on this point, so you can say that force Fx, that means force acting at the point X, that will be, you will suppose if we consider this is a uniform cross sectional area, that means this cross sectional area of the tube, and here it is and here this is basically same. So here it is cross sectional area is area A, here also A and here also A, because this is a uniform cross section. So you can say A into H into rho 1 into G plus P of ATM. So that is the force which is acting at the point X. That means this is the point. So now how you are calculating the force at the point X, that we will just simply multiply this pressure with area. So if you multiply this pressure with area, then we are going to get the Fx, that is the force at the point X. We are going to get these things. Okay. Now we are coming down to this particular point, that is Y. So if we are coming down to Py, then we will say H into rho 2 into G, and that's we are adding with P of ATM. So that is the pressure at the point Y. So now F of Y, so this F of Y is coming down to how much? This is coming down to H into rho 2 into G plus P of ATM. Now you may ask this thing, why you are adding the ATM? P of ATM, why you are adding? The reason is at this point the pressure is atmospheric pressure. So here the pressure will be atmospheric pressure, whatever is acting over here, plus the pressure due to this particular height. So here it is mentioned, you see in this problem it is mentioned the height of this liquid column in everywhere it is L. So from this level to this level you can consider this height is L. From this level to this level you can consider the height is L. The distance is L and this is also L. So everywhere it is uniform. So now you can say that total pressure which is acting at this particular point is this. Now coming down to this particular level. Now the question is, if it is in equilibrium, for example, you are not shifting or you are not taking this particular jar which is filled up with three kinds of liquid, either to the left hand side or to the right hand side. So in that particular case, what will be the flow of this red color liquid? Your answer is very simple, because this flow of the liquid will be, because we know that Fx is greater than Fy. Why it is greater than Fy? Because now see, here it is A into H into rho 1 into G plus PATM. Here it is A into H into rho 2 into G plus ATM. So if you strike it out, then you will see that here it is mentioned rho 1, this particular is greater than rho 3. That means the rightward, that means force acting into the rightward direction. So that is Fx. That will be greater than force acting into the leftward direction. So at the point Y, so this is, suppose the point is Y. So if I consider this point is Y and this point is X. So in this point, the force which is acting to the rightward direction, that is Fx. And the force which is acting to the leftward direction, that is Fy. So Fx will be greater than Fy, because we have seen that rho 1, this particular density is greater than rho 3. So in the equilibrium, if the vessel is kept still, at that moment we will see there will be a movement of the red color liquid into this direction. That means the red color movement, red color liquid will just go inside this particular tube. That means ऐसे हो जाएगा, ठीक है? Now after that what will happen, I am telling you. So normal situations, what will be the movement of this? We have seen a movement of the yellow color liquid into the right hand side, and red color movement, red color liquid will enter inside this right cylinder or maybe right tube. So this liquid will move into the upward side and red color movement of the liquid will be on the right hand side. Now you just imagine that if we want to stop this phenomena, then which side you should move this entire tube. Because already you have seen, suppose if already the liquid is in this position, so if you want to keep the liquid in the standstill, then exactly what you have to do, now you have to move this particular tube in which direction. Now you have to move this particular tube. If you move it into this direction, that means right hand side, then what will happen, this left color liquid will move to this side. So how you can maintain the equilibrium of the liquid in this particular tube? One way, first way. So first way by which you can maintain the equilibrium of these three liquids inside this U tube, that is by moving the entire tube, into the right hand direction. So into the right hand side. So if you just take it into the right hand side, then only it is possible. Then only you can get that, you can able to gather such kind of situation that the liquid will be in still motion. That is one thing. Is there any options which is saying that it is in the right hand side? No. As per this option, say okay, none of this is a different case, but first three option, if you just check, there is nowhere it is mentioned that if you take into the right hand side, then the liquid will be in equilibrium position. Now move on to the, is there any other way by which you can do so? Yes, sir. Here we can do another more thing, that is, here the point is basically, if we take this particular portion and this particular portion, these two portions, so what is the force which is acting into the downward directions? Now here we will see vertically only one pressure is acting, that is P atmosphere, which is acting vertically downward direction from these 2 points. So one thing we can do, if we take, that is the second way what we can do, that is if we take this entire tube, if we take the entire U tube, so this entire U tube, so if you take this entire U tube into the vertically downward direction, so if you take this entire tube into the vertically, if you take the entire tube into the vertically downward directions, so what will happen? Now if you take the entire tube vertically downward direction with a certain acceleration, and then we'll find that the force here, force means what? Force means this liquid weight, basically the liquid weight is this. So if you want to maintain the equilibrium, that means liquid will be static position, that means we have to nullify this particular atmospheric pressure. So what exactly you have to do, if you take into the downward directions, then there will be an upward pressures which has to be in these 2 points. One point is X, another point is Y. So if that upward pressures in this 2 point is basically same as the downward pressures, so we know that particularly the downward at this point, basically the pressure which is acting, that is this one, and this is acting this one. So force, and this is another pressure, that is Py, and this is another force which is acting at this point, Y point. So if we take into the downward direction, definitely there will be a pseudo force which will act at the point X and Y. So this X point and this Y point, there will be a pseudo force which will act vertically in the upward direction, and that means in the point X and Y there will be a pressure which will nullify the point P pressure. Point P pressure means I am talking about point X pressure and point Y pressure. So if you take it into the vertically downward direction with a certain accelerations, then what will happen at the point, whatever the downward pressures and whatever the upward pressure, this each will nullify each other. So that is another way by which you can make this entire system in equilibrium. So what are the two ways that I have explained over here? First thing is, if you take it into the right hand side, then automatically there will be a pseudo force acting in the left hand side, and at that point the pressures which earlier was this, so that pressure will be increased. So what will happen, the entire system will be equilibrium. That is one point. Second point is, if you take the entire system vertically downward direction with a particular acceleration, then a pseudo force will come into the vertically upward direction at this 2 point. I am talking about point X as well as point Y. So if these two forces acting on X and Y in the vertically upward direction, then what will happen? The force which are acting vertically downward, these two forces basically nullify each other. So in that situation, what will happen? The entire liquid it will remain in the standstill position or in the equilibrium position. What you can say, this will be in the equilibrium position. So there are two ways by which you can maintain this situation. Now you come down to the option. Here you see it is mentioned the accelerating leftwards. So no, it is not possible that if you take it to the, you have to take it to the rightward direction. So option A hobe na. Option B is accelerate vertically upward. No, it has to be taken to the downward direction so that the pseudo force act into the upward direction. So option B is not correct. U-tube is moving with a constant velocity. So if you move with a constant velocity, there will be no pseudo force. And if there is no pseudo force, then what will happen? This red color liquid will automatically go into the right hand side. That means it will push the green color liquid into the upward direction. तो ये ग्रीन कलर लिक्विड जो है वो ऊपर तरफ जाएगा और रेड कलर क्या होगा ना, राइट हैंड साइड में जो ट्यूब है, दैट मीन्स ये वाला जो ट्यूब है उसके अंदर ये रेड कलर का लिक्विड घुस जाएगा. दैट मीन्स ये ग्रीन कलर लिक्विड थोड़ा ऊपर चला जाएगा. सो ये तीनों का तीनों ऑप्शन जो दिखाई दे रहा है, किसी भी ऑप्शन करेक्ट होगा नहीं. सो अल्टीमेटली द राइट ऑप्शन विल बी ऑप्शन डी. सो this is the way you have to understand these things, that whenever you are trying to keep the entire system in equilibrium, then what are the two things you can do? Now if you check the options, neither of the options is matching with the first way or second way except D. So correct option will be none of this. So if you have any queries regarding this particular problem, so please make in the comment sections so that we can also publish many more such important videos over different subjects of physics. Thank you. So do subscribe and give a like so that we can create more such video. And if you have any doubts, please do mention in the comment section regarding this problem or the earlier problems. Thank you.